Welcome back to KTAL LP FM in Las Cruces, New Mexico, 101.5 on your dial, and streamed live at lccommunityradio.org. We're in a show that's relatively new, the second week of it happening. It's called Science. Let's take a look. I'm your host, Vince Gutschick, and I've also brought two students with me from the school where I'm the board chair and I teach middle school science. I'll get to them in a second. First, let me say that I welcome you to contact me by email. You can use vince@lascrucesacademy.org, or you can text me at my phone, 575-571-2269. Next week, we're going to have another guest, and that will be Clay Doyle from El Paso Electric, barring any emergencies he has to face. And we'll talk about the electric grid, which is the biggest machine in the world. You've got about 5,000 generators all moving at the same pace, basically. Let me also mention what community radio is. LP stands for low power, which means we use 100 watts radiated power or less so we can reach the city. That way we don't interfere with stations, commercial and other stations that have a wide area of broadcasting. It's also meant to build a community. So one thing we would like you to see is our webpage, which is, again, lccommunityradio.org. There's a donate button because if we don't get the funds to operate, then we won't be here. We've been here for a while, and we hope to keep going. But now, let's get back to these two students. We have Kira Durrett and Arabella Camuñez. Okay, we're live. So, we have been talking about the kinds of science experiments and other things that we've been doing at the Las Cruces Academy, again, our nonprofit private school in Mesilla. And we've been talking during the break about some interesting things that we have done. What was the first one that came up again?
The Chladni plate?
Sure. Okay, you want to describe that? This is Arabella.
Okay, we had a sheet of aluminum and we put it on the on some wooden 2x4s, and then we placed a speaker on it, and based on the different frequencies that came through, we got different vibration patterns in the aluminum, and then we put sand on it, and we got to see the different patterns emerge.
Do you remember why the sand collects at certain places on that plate?
Because it would vibrate certain parts of the aluminum, and it would collect where it wasn't vibrating.
Right, at the nodes, right. And that's really interesting physics in there, but it's just beautiful patterns. And you would only get the patterns at certain frequencies, discrete frequencies.
Sometimes they were really like bleh, but sometimes they were awesome.
Okay, what else did we do that attracted your attention? Kara, we had been talking about it in the break. Oh.
Well, I wasn't exactly here for this, but they were talking a lot about lighting magnesium.
Yes. Okay, not a spoiler alert, but just to say, nobody ever got burned, nobody burned out their retina. We were careful. But one thing did happen, that was...
We accidentally set the fire alarm off with the smoke, and we had no idea that we had set it off. And everyone was going outside, and eventually they figured out it came from the science classroom, and we're like, oh.
Yeah, because you know how a smoke detector works, right? It has typically americium as a radioactive element. It's giving off these rays that will let the air get ionized and be conductive, but if you get smoke particles in the way, it cuts that current, triggers the circuit that sets off the alarm.
Yeah.
There was something else that we just talked about. What was it? Elements, getting to handle the elements. Okay. Kira, you were there when we did the introduction to the elements for the younger kids, right?
Yeah.
What elements?
Stuff
Do you
like
remember?
mercury, gallium, bismuth.
Lots of metals.
Yeah, lots of metals.
Okay, we didn't actually take the mercury out to handle it, but we did with gallium. What's so cool about gallium?
It's liquid at room temperature, so when we put it in our hands, well, when it was really cold, we'd have to like use our hand warmth to melt it, but when we'd put it in our hands, it was like this little ball of liquid metal in your hand that would just keep moving around, and it was awesome.
It looks a lot like mercury.
Yeah.
But is it toxic at all?
I don't believe so.
Yeah, there's no good reports of it being toxic. So, but does an interesting thing. What happens if you streak it across your hand?
It leaves a...
It was gray, right?
Yeah, leaves a layer that looks kind of like graphite.
Do you remember streaking it across a glass bottle?
No.
It makes a mirror.
Yes, I do. That was really cool, yeah.
And how about the putting it on an aluminum can? So, Kira, you said you weren't there for that one?
No, I was not there for that.
You were not, okay. But you remember, that's because it was done at our house during what we called Science Sundays.
We just took a can and we put gallium on it, and we didn't, at least the students didn't really know what was going to happen, and so we watched it, and it, like, disintegrated the top of the aluminum can, which was really cool.
Right, because it makes a very brittle alloy. The gallium atoms get alongside the aluminum atoms and disrupt the crystal structure, so it becomes something that just falls apart in flakes. Okay, so were there other things that you wanted to mention about science or the school in general? Does science complement the other classes there? What kind of classes do you take?
We take classes like math, science, Spanish, Chinese, computer programming, social studies. Some people take geography.
Right, and I know that I'm sort of the grammar enforcer. So you'll be out on the tennis court and say, me and Andrea or whoever, make up a name, are going to, I said, no, Andrea and I, right?
Yeah.
And that happens in every class.
Every single class.
So we do a lot of math in the science, right?
Yes.
It's a very quantitative course, and that's basically reflecting my background, coming from chemistry and physics and then getting into biology. Llewellyn still, well, if you missed that segment, she's my wife and the founder of the school, a real biologist. And sometimes when I made some real mistake in biology, she would say, "And they pay you?" But it's been a great ride doing biology that way. Let me think now. If you want to have any other comments about science in the school or what really interests you. Okay, well, thanks for being guests on the program. I will continue. I've got a segment that you might find interesting too, and that is Smart Water. Have you heard of Smart Water?
Yes.
It's a Coca-Cola project or product. Sells for over $2 for a 20-ounce bottle. I didn't even know it existed, but our son David Gutschick texted me in a Google Hangout. He said, if you pay $4 a bottle for Smart Water, it's not working. So true. Why would anybody buy, well, even bottled water? Now, Smart Water has some special claims, which mostly I think are pretty outrageous. But bottled water is how many times more expensive than ordinary tap water? Let's say you get this Smart Water and it is $2 for a 20-ounce bottle, so it's about $12 a gallon. What's tap water? About $2 for 1,000 gallons. So it's about 6,000 times more expensive than bottled water. What's the advantage? Well, portability. If you're not near a drinking fountain, whoopee. Okay. But also, it is no purer than most tap water. In fact, most tap water is purer than bottled water by independent laboratory analyses. If you think about taste, there's some pretty funny stories that, for instance, one restaurant put out bottled water and gave it fancy names like eau de robinet, which just means tap water. And people were going lyrical about the taste of this water. Tap water has taste. If you take purely distilled water, really pure, you have to add things to it to have taste. So Smart Water says that it's been vapor distilled. Okay, that gets rid of the non-volatile contaminants that might be in the water, uranium, lead, and all that. I should mention that you pretty much can't avoid uranium, lead, and arsenic. They're everywhere, and they're always present in very small quantities that don't affect us. Okay, so the things that it doesn't remove would be volatile organics, unless they charcoal filter it out somewhere. Those are pretty hard to remove, and there are some that are of concern, particularly in certain areas of the country, certain water sources, aquifers. But then Smart Water says they add calcium, magnesium, potassium. Potassium's radioactive, you know that. About 1/100% of potassium is potassium-40, which is radioactive. It's a so-called beta emitter. It actually has 3 ways to decay. And we can't avoid having potassium in our bodies, much less in our water. We need it as a metabolic thing. Also, it's doing this radioactive decay while it's in our body. Again, unavoidable, so are cosmic rays. So we'll skip the thing about whether potassium is a problem. It's not. We need it. Okay, they don't add sodium to Smart Water. Good idea. We get more than enough sodium in the American diet. But when you finally get down to it, why pay 6,000 times more per volume of water for something you can get at the tap that's at least as good? So we'll take another break here, and we'll be back in a few minutes. You're listening to KTAL LP FM in Las Cruces, New Mexico, a community radio station. It's 101.5 on the dial. It's also streamed live at lccommunity.org. We'll be back in a little while.
Catch